Good morning, students. Previously, we discussed about pure and impure substances. Now, today we'll be discussing about these three topics: solutions, suspensions, and colloids. First of all, we'll discuss what is a solution. A solution is defined as a homogeneous mixture of two or more chemically non-reacting substances whose composition can be varied within limits. A solution has two components. First is a solute, second is a solvent. Let's see what is a solute. A solute is actually the component which is dissolved or which is present in smaller amount, that is called a solute, and it is also called a dispersive medium. And second is solvent. The component which is present in larger amount is called a solvent, and it is also called dispersion medium. Actually, what we do is we dissolve this solute into solvent and we get a solution. Let's take an example here. Like as you can see here, this first one is a solute. Let's say it is a salt. This is copper sulfate salt, and this is blue in color. And here we have taken a glass containing water, and here it is solvent. When we compare these two, we find that the amount of solute is less as compared to that of solvent. And when we mix this solute into solvent, we get solution, right? So solute and solvent together form solution. Now this will be a salt solution, that is solution of copper sulfate. Now there are different types of solutions, like first solid and liquid, like sugar which is dissolved in water, or tincture of iodine. This is also an example of solid and liquid. Second is liquid and liquid, like alcohol is soluble in water, and when it dissolves in water it forms a solution. And third is gas and liquid. Like you must have observed, there is some gas which is present in cold drinks, and that is carbon dioxide. So this is an example of gas and liquid. Fourth is solid and solid, like alloys like brass and bronze. Brass is actually an alloy which is constituted by two different elements, copper and zinc, whereas bronze, it is constituted by copper and tin. But point to be noted here that solids, they cannot be directly mixed into each other. They should be first of all converted into their molten state. Only then you can mix them. And next is gas and gas. Like in air, various gases, they are mixed together, like oxygen, nitrogen, carbon dioxide. So that is an example of gas and gas. Liquid and solid, like copper sulfate in dental amalgam, and solid and solid, gas is absorbed over the surface of metal. So that is an example here. And solid and gas, like camphor in air. Camphor is ammonium chloride, or which is also called kapoor in Hindi. Next is liquid and gas, like clouds and fogs. These are also examples. Now let's see what are the different properties of solutions. These are very important. And first property is solution is a homogeneous mixture. That means the constituents of a solution, they are uniformly distributed throughout. Second, size of particles is very small, that is smaller than 1 nanometer. A nanometer is a very smaller unit, and which is equal to 10 raised to power minus 9 meter. That means it's a very small unit. Next is the particles cannot be seen by microscope. That means they are very small, that they are not visible to our naked eyes, and even if you use a microscope, that will also not be able to show you the solution particles. Next is a solution is a stable mixture. Solute does not settle down over a period of time. And next point is, if solution is passed through filter paper, solute and solvent do not get separated. That means suppose if you have taken a solution of salt in water, once you have dissolved salt into water and try to separate it out by using filtration, will you be able to do that? No, you will not be able to do that. So that is the property of solution, that they cannot be separated by simple filtration. And next point, a solution does not scatter light, which is also called Tyndall effect, which we'll be discussing later. That means whenever a beam of light is passed through any solution, it will not scatter away the light. So let me tell you what is Tyndall effect here. The phenomena of scattering of light by the particles of the medium, which makes the path of the light visible, is called Tyndall effect. As you can see in this picture here, sunlight is passing through the forest, dense forest. So the air which is present in this forest, it is scattering away the light which is coming from sun, and as you can see these rays here, so that means it is making the path of the light visible to us. So such an effect is called a Tyndall effect. Now our next topic, that is suspension. A suspension is a homogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of medium. Like suppose if you mix sand or soil with water, you get a mixture, and that is an example of a suspension. Let's see what are the different properties of suspension. It's a heterogeneous mixture. Yes, this is very important to be noted here. It's a heterogeneous mixture. That means the constituents, they are non-uniformly distributed throughout the given medium. And second point, the size of the particle is greater than 100 nanometers. That means they are comparatively bigger in size, so the particles, they are visible to our eyes. Third point, yes, they have written here, particle can be seen by naked eyes. Fourth, it is unstable mixture. Unstable means, suppose if you prepare this suspension and if you leave that undisturbed for some time, you'll see that the solid particles which are heavier, they'll settle down at the bottom. The solute settles down at the bottom over a period of time. So such a mixture is called unstable. Fifth point is, if the solution is passed through filter paper, yes, all of you know what you'll get is, you'll get both the things separated. So that means the constituents of the suspension, they can be separated by the process of filtration. And sixth point, it scatters light when light is passed through solution. That is, it shows Tyndall effect. Yes, previously in a true solution or solution, there was no Tyndall effect. A solution doesn't show Tyndall effect, whereas a suspension shows Tyndall effect. That means whenever light is passed through a suspension, it will scatter away the light to make the path of the light visible to us. So this is an example which I was telling you, that is here it's water and soil mixed together. As you know, both of them, they are not completely miscible into each other, and as you can see, some particles, they are suspended here, some are floating, some have settled down. So this is an example of a suspension. Now next is colloids. Solutions in which the size of the particle lies in between those of true solutions and suspensions, they are called colloid solutions or simply colloids. Colloids, solution in which the size of particles lies in between those of true solution and suspension. So the same thing is repeated here, and that means colloids, they are in between true solutions and suspension. So this is the best example we can take here. There's a glass which is containing some milk into it. So milk is an example of a colloid. Now let's discuss what are the different properties of colloid. First of all, first point, it's a heterogeneous mixture. Heterogeneous, again, that means the constituent particles, they are non-uniformly distributed, although they are very small, that they are not visible to our naked eyes. And second point, the size of the particle is smaller than suspension but greater than solution. That is, it ranges in between 1 nanometer to 100 nanometer. And third point, particles, they can be seen by microscope, but they are not visible to our naked eyes. Fourth point, it's a stable mixture. Particles, they do not settle down at the bottom over a period of time. And fifth, when the solution passes through the filter paper, the solute and solvents do not get separated. That means you cannot separate out the constituents of a colloid simply by filter paper. Now, these are different types of colloids. First of all, you should be aware of these two terms, dispersed phase and dispersant medium. So dispersed phase, this is actually the solute component of a colloid, whereas dispersant medium is actually the solvent component of a colloid. And here this is a table which shows different types of colloids with examples. First, solid and solid, that is called a solid sol. Some colored glasses and gemstones, these are examples. And second, solid and liquid, which is called a sol, like paints, cell fluids. Third is solid and gas, aerosols like smoke, dust, these are examples. Liquid, solid, gel, they are called gel. You must be aware of gel, like jellies and cheese, these are examples. Liquid and liquid called emulsion, like milk, hair cream and butter. And next is liquid and gas, aerosols like fog, mist, cloud, insecticide sprays, these are examples. Gas, solid sol, like pumic stone, these are very light weighted stone and they can even float on the surface of water. And foam, rubber, they are also examples of solid sol. And gas and liquid, which is called a foam, like froth, whipped cream, soap, leather, which is actually जिसको हम झाग बोलते हैं. So this is all about today's topic. So today we discussed about three things: solution, suspension and colloid. I hope you have understood all these three topics. Thank you. Thanks a lot.